a class, we're going to do either hard to remember or miscellaneous items. At a minimum, I want you to write down the first thing because it's new. It's actually an A-B topic that we didn't cover last year because they took it out because of the format. At most, if you don't, it's usually like a 2-day topic. We're going to do it in about 10 minutes. So if you don't get it, at a minimum, or at a maximum, I mean, you'll miss one multiple choice question. And it's not something that's always on the AP test. It pops up sometimes, but not very often. But just in case, I don't want you to go, oh, I knew them all, except she never taught me that one. And you could be the one person in the world who aces it and allows me to retire, which will never happen from Elk River, but maybe it could. Well, come on. It's going to come from some math private academy in like Japan or something. But I would love it, Gabe. You got it. You got it. You got somebody. Nobody in the world has the last 2 years. So. Anyway, just in case, it would be cool. Anyway, we're going to cover it. So, because I'm recording. At a bare minimum, listen to that first part. If I lose you, just nod and smile. Be like, I don't care if I might lose 1 point. But if you get it, hold on to it for 5 more days. Then we're going to do a few things that people tend to forget from AB. Okay? And one is the second derivative test. The other is inverse function derivatives. The other is just stuff that comes up maybe in a weird format. And then average issues. Formulas I'm not going to cover, but you need to know formulas. When we're done with that, you're going to hop on that sheet I gave you yesterday, distance learners. It's attached here. And you're just going to peruse it and be like, do I know this? Do I know this? Do I know this? Do I know this? No, I forgot this. All right? You're going to hop onto Khan Academy and you're going to find that topic. All right? So I want you to do at least 1 topic. And if there's 5 things you don't know, I would like you to do 5, but that's on you. All right? I don't want to force anything, but we're kind of at the end here. So what we're going to do is go on a blank sheet of paper, and we're going to talk about the formal definition. You might say, we did that. We did it of the derivative. We never did it of the integral. All right, the definite integral. So we're going to start with that. So what I want you to do is draw yourself a fake representation of a fake function f from an interval from a to b. All right? And what we're going to do is write the definite integral in its formal notation. We've never done that before. At most, there'll be 1 multiple choice question where they either give you a definite integral and ask you for its formal notation, or they give you the formal notation and you have to match it to the definite integral. So first of all, what do you add up under the area of a curve with this notation? What are you actually adding up? An infinite number of rectangles. So it becomes a limit, and I'm glad you said infinite, Emily, as n approaches infinity of a sum. Now, when we go to infinity, we actually have to have n approach infinity, but we need to have a counter. I'm going to call it I, because that's kind of what you're used to from series, but sometimes College Board will call that a k, so we'll do an example with a k. So all that notation is I'm going to add up an infinite number of things. The first thing, the second thing, the third thing, the fourth thing, the fifth thing, the sixth thing, and out to the infinity thing. Okay? What are we adding up? To infinity, area of rectangles. Okay? So I have to give you the formal notation for any definite integral of the area of the rectangle. First, we're going to approach it with a finite number. So I'm going to pretend this was at 2 and this was at 8. Okay? The distance between those is 6, b minus a. Agreed? We're going to go b minus a. We're going to chop the whole distance up into n rectangles as n approaches what? Infinity. So b minus a over n. Let's pretend it was 2 to 8. And let's pretend we were chopping it into 6 rectangles. Right? Let's go do that. That hit on the right. 1, 2, 3. I'm trying to make them the same width, but I'm kind of 4. Oh, I think I'm going to do okay. 4, 5. So 1, 2, 1, 2, 3, 4, 5, 6 rectangles. But pretend that n was actually going to infinity, but I want to show you it with a finite. What is the base length of every rectangle? 1. Right? It's b minus a over n. This is actually the dx. Okay? So there's going to be a b minus a over n out here as n goes to infinity. That's actually where you're going to look first, because that actually eliminates some of this. At worst, you should be able to guess between two of them. All right? If that's all you understand, it usually narrows it down to 2. So on this one, my b minus a is 8 minus 2 over, and I said 6, so it's 1. Agreed? Well, now what does this stand for? The function's y value. What is it of every rectangle? The height of every rectangle. Correct? It's the height of every single rectangle. Well, how do we get that? You said the function, right? Evaluated where? And I'm just going to put, well, depends on what rectangle I'm on. That should make sense to you. If I was 3, I'd be at the third rectangle, and I'd do the function at f of x of 3, the third one. Does that make sense? But remember, I'm going to infinity. So we're going to fix this a little bit and figure out, well, how can I write that with more notation? How are we doing so far? We doing all right so far? Okay, it's getting a little funky with our notation. If you don't get it, you're just still going to watch your non-smile. I'm going to think you get it, and you're going to okay? And if it bugs you, that'll be the Khan Academy one you watch. All right. I feel like I really want to get it. I wish I had the 2 days. Go do that. All right. Khan Academy actually has a good practice set on this. Anyway, it would have been one of your assignments last year. So do you notice how this is at 2? It's starting at 2. And do you notice how that's starting at a? And then this is up 1 delta x, right? And this is up another delta x. And the third one is up 3 of the delta x's, and then 4 of the delta x's. In my case, it's 1. But you're adding, for the ith rectangle, aren't you adding up I of those delta x's to get there? Right? So what that becomes is a limit as n is approaching infinity. I'm writing really neat today. I'm so proud of myself. We're proud of you too, LaRue. Thanks, guys. So where was I? So we're evaluating the function at, all right, where are we starting it at? The lower limit. That's going to be helpful because if you're given L, well, I don't want to use natural log because I'm going to do an example. Just wait. You're just going to leave that there. All right. So this, if you're going backwards, this lead number in whatever function it is, whether it's cubing or a root, let's suppose it was a square root function, and you saw the square root of 4 plus, and then you saw some stuff, that's the lower limit on the definite integral, because that's where we start, all right? And then where do we go? We go up delta x for the first one, 2 delta x's for the second one, 3 delta x's for the first one, and basically I delta x's. But what's delta x? Just one second. What is this delta x, really? It's 1 on my example, but formulaically, what is it? B minus a. All right. B minus a over n. All right. Oh, now if you don't get that, watch up here. For the fifth rectangle, I would do f of 1, 2, right? And then I would do 5, and mine was 1. So for the fifth rectangle, I would do f of 7. 2, 3, 4, 5, 6, 7. Boom. Is that the height of the fifth rectangle? Yes. Okay. Now watch. I still have the b minus a over n from, here we go. Now, here's one thing to notice. The thing in front of the count, go point at that. So if you kind of get it, there's a few little things that'll help you at least eliminate some wrong answers. I think I need one more set of parentheses. No, I'm good. Notice that there's a match there. Match. Now, if you don't get it, that's okay. So it's okay. We're going to do 2 examples, one forward, one backward, and then I'm going to see if you can at least narrow it down to 2 on 2 past AP questions. It's weird. What was that? F of A. Oh, yes. Thank you. Thank you. Is that what you were trying to? I was like, just hold off on your questions. Let me. Thank you. You're so smart. Now, here's my first example. All right. I want to make them math out. They can be harder or easier than this. I'm going mid-level. All right. Here we go. We're going to take this definite integral, the integral from 3 to 5, under x to the 4th, a quadratic but an easy one, dx. And the first thing we're going to do, and you won't have to do it. It's never been part of an FRQ. You might have to recognize it. So when we practice it like this, it's actually harder because it's not multiple choice. So if you can do this, you can definitely do the multiple choice. We're going to write that. You're going to be matching it with its limit definition or its formal definition. It is the limit. That's not going to help you at all because they're all going to have a limit there. They're all going to say as n approaches what? Infinity. They're all going to have a sum. They're all going to have a count, either I or k. I'm going to use I on this first one because that's what I used in the model. But the next one I'll switch it to a k. So that College Board makes it a k or a q or whatever. It doesn't matter. It's just the next rectangle. As it goes from 1 to n, that won't help you eliminate any. They're all going to have that. Okay? So the first thing we need to do is I like to figure out my b minus a over n, because that's the length of every rectangle. So I actually go to there's 2 parts to this, the heights and the bases. But the bases are always the distance chopped up into n pieces, correct? So what do you think I would see at the tail end of this? 2 over n. That is the base length of every rectangle. If n was 8, I'd go by fourths. Okay. Next is the height. Okay. My function raises to the 4th, or your function square roots, or your function natural logs, or your function e to this. All right. Where do I, like if I were to graph x to the 4th, actually that looks like a parabola that's just kind of got a flat butt on it. Okay. Or, you know what I mean? All right. And if I were to go from 3 to 5, right? My height, and if I did a finite, this would be the height of the first rectangle. This would be the height of the second rectangle. But I am already starting how many to the right? 3. So it's going to be 3 plus, you see how we're working with it? And so it's going to be 3 plus I, there's my count. So if I'm on the 99th rectangle out of an infinite number of them, I would have started at 3 and I would have added 99 what? Right, but 99 delta x's. Like for the third one, I would do 3 plus 3 delta x's. And if delta x was a half, I'd do 3 1/2, 4, 4 1/2, and I'd calculate f of 4 1/2, correct? So what's going to be right here? 2 over n. Notice the match. That's helpful, correct? So if you don't see a match there, it's super easy to get the second part. Wouldn't you agree? All right, that's the only example I'm going to do of that. If we were actually doing this in AB with everybody, that's all we would do today is just practice this kind, and then we went and practiced on Khan Academy, and then we went and practiced going the other way. You're getting one of each, and then I'm going to see if you can maybe do a couple. If you can't, no big deal. Okay, then we're going to gloss over really quickly, just bring back a couple things that you already know. All right, so my next example is going the other way. If you are given the limit definition, as n approaches infinity, of the sum, and I'm going to use k this time just so you don't memorize with i's, because it's really just the count. It's the 473rd rectangle's height. All right, is what the first, the second, the third. We're going to add them all up, right? K goes from 1 to n. I'm going to do this. And I'm not even going to have you try it on your own. I'm going to talk you through it. All right. So here we go. Here's what I suggest you focus on. At a minimum, the easier part first. I would go to 2 places and use those to get your limits. If you don't understand what I'm saying, you're nodding and smiling. I would go to this to get my what? My lower limit. I would go to this. It's not my upper limit, but b minus a is 4. So it gets me the b. What is it? 7. What's my function? Natural log. Of what? X. That's what this is. It's just the x1 starts at 3 and then I'm moving along. I hope that makes sense. If not, right? And what's the 4 over n? It's done. It's done. That's what you would match it to. So now I'm going to show and blow up a couple that are past or similar to, they're either on practice exams or real exams. And you're going to just maybe, if you get it, it's great because you can do it in your head. If you don't get it, it's fine. You'll at most lose 1. Here, let's go to this one first. This was actually an AB. Whoopsie. Sorry. Here's an AB, BC exam put out by College Board. So this is one of theirs. It was in one of theirs. They're hard to find. Why do I say they're hard to find? I got to search. They don't come up very often. But go ahead and see if you can. If you get it, you don't even need to write anything down. Don't worry. Yes. All right, now I have to scroll up a little bit. Just a second. Oh, no, we didn't. Did I do that exact one by accident? It was in my head. Well, see if you can figure it out backwards. Just think it through. I've got 2 more, so no big deal. Shh. I know, but pretend you didn't. Be quiet. Where on the integral would you look for? We'll use this one as a chat. Just if I hadn't done this one. Where on the integral will you look first? The limits. B minus a is 2. 2 over n is delta x. Out goes a, out goes c. We're now at a 50-50 guess. But we don't want to do that. Correct? So then I go to the lower limit. And it has to start at 3. And I go, oh, they all do. But it's 3 plus the count, which is k, times what? Delta x. Right? Which is which one? D. All right, let's go try. So, oh, I'll blow them up. Don't yell at me. I'm blowing them. I'm blowing them. All right, now don't blurt. Can you guys see it back there? Do I need a little bigger? I think I can go a little bigger. Maybe one more? Nope, I have to go back one. So don't blurt, please. And even if you don't get it, just pretend you're doing it in your head. I won't know. It's actually easier than the formal definition of the derivative. It's just weird. We're not doing BC. This is an AB topic that we were told we didn't have to cover last year, and we were really pressed for time, remember? Yes?
So will it just say you find the formal definition?
No, it'll look like this.
Oh.
Yep.
Oh, yeah, okay.
This is one. It'll either look like this, where you're going forward, or it'll give you a limit and you have to go backwards. I don't know. Or probably there won't be one. Because this is a weird year, and if I were writing the AP test this year, I'd say, you know what, let's not go there with everybody doing distance learning. But just in case. All right, so in your head, you're going to decide. Did I give you enough time? You decide if you got it right. First thing you should do is go think about the base length of all your rectangles. They were 2, but we're chopping them up into n rectangles. So every base length is 2 over n. That's your delta x. It's either b or it's d. Then I would go say, well, where does this start? By the way, if this was a 0, you won't see anything. You'll just see delta x attached to a count. And you'll go, oh, there's nothing there? Well, then your lower limit's 0. If you don't get it, fine, nod and smile. All right, so it's going to be 1 plus, oh, shoot, that didn't help me. My count, which in this case is an I, not a K, so it could be an L. It won't be. It's usually I or K. And it's not, which one is it? Is it I over N3 or is it I over N with the 2 in front of it? It's D. It's the one with the 2 because it's the... okay, I think we got it. I'm going to have you try one where you're going the other way. So shh. So Luke asked, is this going to say? It's not going to say. It's either going to have you match, if at all, which I don't think. But we're at the point where we kind of know everything right now for the most part. When I start getting people getting in the 40s on the multiple choice, I know I have to spend some time on new thing. All right, so you might need to write down for this one. Your brain has to go in reverse. You should be able to at least eliminate 2, just based on, I'm just going to let you think. Are we good? I'll give you enough time for those of you trying it. All right, so I said you should at least be able to eliminate 2 because you know your lower limit. Okay, but you know that delta x is 3, b minus a is 3, which means your upper limit has to be 2. We're now at A or C. Which one is it? It is A. Yep. Kids who don't get it, what do they pick? C, because it looks better for the problem, but it's not it. Are we good? You want to try one last one? I don't have any more of that kind. Unless I have one. Nope, I don't. Okay. You actually liked that? I thought you guys were going to be like crabby at me. Oh, that's funny. What a bunch of weirdos. No, if you want to practice that, you can choose that as one of your things with Khan. He's got a really good 4-problem practice set, I think, one each way. But it's a waste of time, really, kind of, if you get it, because at most, what's it going to be? Yeah, so I would look at something, maybe you have a little bit more. All right, so next thing. This is going to be some miscellaneous, just remember if. Okay? One thing that AB topic that people tend to misinterpret or forget is the second derivative test. Not that you need to know its name, but you have to know that if the first derivative test is not possible to run, you can run a second derivative test. And you might say, oh, that's about concavity. It's not. The second derivative test is a test for relative extrema. Normally, you use the first derivative test and you make a sign line, right? And you say, well, if it goes from positive to negative for f prime, we must have had a relative max. But there are situations where you don't have f prime made available to you. You only have f double prime made available for you. Okay? So if f double prime at a critical value, what's a critical value? Anywhere where what happens? The first derivative equals 0 or doesn't exist. Normally we evaluate f prime there, but if we can't, if you don't have that available, maybe there's a table where there's only f double, or maybe they tell you f double prime is this, and it's something ugly that you can't anti-derivate. If f double prime of c is less than 0, so suppose you knew there was a critical point at 2, but you had no way of getting f prime, well, you know f prime of 2 is 0, but you have no way of running a sign line test. But you can figure out the second derivative. What does it mean if we're less than 0, we're concave down? So we had a maximum. Exactly. It means there must be a max. Will you have to use that? Very rarely, but it gets forgotten. Usually kids struggle and they're like, I can't run the sign line. Well, maybe you can figure out that the second derivative was positive there. Maybe they told you. You're like, you got a critical value at 3 and f double prime of 3 is negative. What is it? Oh, it's a max, right? So if we're positive, then what is it? Min. If it equals 0, it's inconclusive. So that's not helpful. So that's my first one. I'm not going to do examples of that. My second one was inverse function derivatives. Remember that one? It was always, I told you last year, I said it's always easy the day we do it, but people forget it. So inverse function derivatives. And I'm just going to, actually, I think I'll just put a sample. Well, do you remember how they're related?
No.
How are the derivatives of inverse? Think about derivatives. Derivatives are changing y or changing x, right? They're slopes. With inverse functions, what happens to x's and y's? They swap. So what do you think happens to their derivatives? They flip.
Yeah.
Right? They're reciprocals. So if you can find the derivative on f inverses you flip. Or if you can find the derivative on f inverse, then f's you flip. So you have to be able to get on a function. So usually they'll say something like this. G equals f inverse of x. What's another way they could say that? And you'd have to, oh, those are inverses. G of f of x equals f of g of x, or they might just say f and g are inverses. Okay? But if g is f inverse of x, they might say find g prime of, let me pick my favorite number, -2. I don't even know why I chose that. What do you know? You know that there's an x value of -2, and you're finding the slope there on g. I mean, the point has to be there for you to get the slope there. Do you remember where it went from here? Well, then I'm going to hop on f.
Oh.
Somewhere on f. This right here, how you get it, depends. Usually, they hand it to you. It'll say f of 4 equals -2. You know what I mean? You can just be what, or it's on a table, right? You remember that? You just have to go grab it. So let's pretend that they told you 4 -2 was on f, or you went to a table and you're like, what got mapped to -2 for then? So here's your two corresponding points. The information given is always on the one you're not looking for. So this one, you would have been able to figure out f prime of 4. You might say, how? It's either handed to you in the stem of the problem, or on a table, or maybe there's a graph of f, and you're going to find it's sloped at whatever. It doesn't matter. We're not going to practice like this a full day. But suppose you get it to be 1/3. You don't circle that because you want g prime's derivative, which would be, that's all I'm going to say about that. If you need more, have that one be one of your cons. All right. I had one more thing. I wrote it down so I wouldn't forget because I didn't want to go back to the inverse. Oh, average. The word average. Be careful with this word average because it can be used multiple ways. All right, so we're going to talk about it in a few different ways. An average, whoops, it helps if I have the R in there. An average rate of change of f, also known as an AROC. It's a slope of a secant line, visually. What is it formulaically? And it would be on an interval, on a closed interval from, let's say, A to B. F of B minus f of A over B minus A. Be careful. That is the average rate of change of f. Watch me do this. It's kind of, let's eat grandma. Let's eat grandma. Right? What's the rate of change of f called? F what? Prime. Then we would be thinking, well, I need the average value, or average of f prime. How do we do that? 1 over b minus a times the integral from a to b of the function of which we are averaging. What's the antiderivative of f prime? F. It'd be f of b minus f of a over b minus a. Do you see how they're the same thing? So if you're given the rate of change and they ask you for the average rate of change, you got to do this sucker. Right? So now watch it with velocity. Average velocity. That word average can be tricky. Average velocity, how do you find it? I'm going to tell you it depends on what you're given. If you know the velocity or have a model for the velocity or a table with the velocity, then you do it one way. If you have the position or know the position or a table with the position, you do it another way. But they're actually the same thing. So suppose we think about physics. Okay? Your average velocity is equal to change in what? Position over change in what? Time. So if you have position available, you would do change in position over change in time. If you're given a table that charted your position at given times and it says average velocity, you would do this. Let units help you. Feet per second. That's a velocity unit measurement, correct? But if you were given the velocity function and it says find the average velocity, it'd be the average value. I'm just going to put b minus a for the times, but really it's t2 minus t1 now, right? From a to b of the function of which you are averaging. But what's the antiderivative of velocity? Position. So that'd be x of b minus. Sometimes this is where stuff that you were like, what last year kind of. Those are the same thing. You might say, well, I like this one better. Well, if you don't know the position, you can't use this one. You might say, well, I'll just integrate and get the position. If you don't have a function for it, you can't. Do you see what I mean? If it's just a table, suppose you've got a table. You guys are super listening today. If it's got a table like that and it asks for average velocity from maybe 1 to 8, you're just going to do this minus this over this minus this, change in position over change in time. But if they tell you, maybe it's calculator active, b of t equals this icky function, and ask you for average velocity, you're going to do math 9, 1 over whatever the interval was, right? Your velocity function. They're the same. So, but I have to tell you both of them. We have another thing with the word average in it called the mean value theorem. I'm not going to go through that because I think most of you remember that, but if not, that can be your con. So we're done. You're going to